Hi, 7th graders. We are on lesson 3-4, identifying and classifying numbers in the real number system. So if you open up to page 155 in your book, you can follow along. Some of this information is right from the book. But if you can remember, when we were talking about rational numbers, remember whole numbers and integers and fractions and negative fractions are all rational numbers. Even fractions that are repeating, that they go on and on forever, but they're repeating, those are still rational numbers. Irrational numbers, if I go down here, are numbers that cannot be expressed as a fraction, or basically a number that is not a rational number. So we can see that the square root of 2 is approximately this whole long number, and it goes on and on and on and on. It's not repeating, so therefore it's irrational. Same with the square root of, or the negative square root of 3. Okay? So here's the same exact table bigger, so I want you to write this in your notebook. I want you to copy this whole square right here and with the different parts and label it. So take a second and do that. You can pause me and then we'll fill in our square. So all real numbers, so the real number system consists of rational numbers and irrational numbers. Okay, so it's two different categories, rational and irrational. Within our rational numbers, we have whole numbers and integers. So if a whole number, for example, 4 is a whole number, we would put it in our whole number category, but 4 is also an integer, and 4 is also a rational number. So 4 would go into the category of whole numbers, integers, and rational numbers, as well as 1, which I can't seem to get right here. 1, because it's a whole number, it's a positive and it's a whole number, as well as 121 and 6. Integers are negative, include the positive and the negative. So all of these numbers right here are also integers. Okay, negative 4 is not a whole number, so negative 4 would only be an integer and a rational number. Okay, that's all I have for that. 8.4 would be a rational number because it's a decimal and it stops. Same with 0.0196. Same with, that is it for now. If we type into our calculator square root of 77, do that really quick. Square root of 77, we get a whole long big number, 8.7749, going on and on and on and on. Remember, even though it looks like it stops on your calculator, it is still going on. It still means that it's going on and on. So square root of 77 is irrational. So the square root of most non-perfect squares, so 77 is not a perfect square, the square root of most of those numbers are irrational because they are just a whole long big whole number with a decimal. Square root of 38, figure out what that is, 6.1644, going on and on and on forever. Square root of 20 is 4.472, going on forever. So square root of 20 is irrational. Square root of 36, well, we know that 36 is a perfect square actually, so square root of 36 is 6. So we would actually put this into our whole number category. Okay? Negative square root of 9/16. So the square root of 9 is 3. Square root of 16 is 4. So we would have 3/4 and make it negative, so negative 3/4. It would go into our rational numbers because it's not a whole number, it's not an integer, but it is a rational number. Square root of 144 is 12. Take the negative, so it would be negative 12. So we would put that in our integers. category. So recap, all of these numbers in our whole number category is also an integer and also a rational number because it's inside our rational box. So all of these numbers in here are rational numbers. Okay? The ones outside of the yellow circle but inside the blue circle are integers. So they're integers and rational numbers. All of these are whole numbers and integers and rational numbers. All of these numbers are irrational numbers because they cannot be expressed as a fraction. It's a decimal that goes on and on and on forever, and it's not repeating, and it doesn't stop. Square root of -9. Well, we know that 3 squared equals 9, so square root of 9 equals 3. We also know that -3, I like to always put it in parentheses so we know that it's -3 squared. -3 times -3 is 9. So the square root of a negative number is actually not possible because the square root of any number is going to be positive because two negative numbers multiplied together is always a positive number. The only reason it would be negative is if it has a negative in front of it. So we're going to leave -9 outside of our box because it is not a real number. It is not rational. It is not irrational. It's not real. So you're going to leave that outside of your box. If you want, you could circle it and label it as non-real. Okay, so if we want to compare numbers or compare real numbers, we need to look at both of the numbers given to us. Well, square root of 7. So if I put that into my calculator, square root of 7 is an irrational number that goes on and on and on forever. I am going to round it to, I'm going to have it be approximately 2.645 Okay, and I know that 2 2/3, well, I know that it's 2 point something because 2 is our whole number, so 2 point, and I know that 2/3 is 0.6 repeating. If you want to check that on your calculator, you can go 2 divided by 3, and you should get 0.666666. So we have 2.6666 repeating forever and ever and ever. Okay? I put my approximate sign here because I rounded this up, so it's approximately 2.6458. I didn't put an approximate sign here because I put my dots here and I know that it goes on forever. So in my tenths place, I have a 6. So I need to go to my hundredths place, and I see I have a 4 and I have a 6. So I know that this one is greater because 6 is greater than 4. 6 hundredths is greater than 4 hundredths. So I know that the square root of 7 is less than 2 2/3. Okay, if I have 1.5 repeating, that means it's 1.555 and so on. The square root of 2.25, which you can check on your calculator, is exactly 1.5. Okay, there's a 5 in both of the tenths place, so then I look at my hundredths place, I have a 5. I have nothing here. Remember, I can add as many zeros on as I want, and it doesn't change our value. So 5 is greater than 0. So 1.55555 is greater than 1.5. So 1.5 repeating would be greater than the square root of 2.25. Make sure that you're writing these problems down, the question and the work. Okay? So I want you to pause the video right now and take a second to do these 3 problems. Come back and check your work. Square root of 11, we can put into our calculator, is 3.3166 approximately. 3 1/3. We should know that 1/3, it's just something that we should memorize, that 1/3 is 0.3 repeating. So 3.333333, and so on. Okay, so my tenths place, we have a 3 in each. So I look at my hundredths place, I have a 3, and I have a 1. I know that 3 is greater than 1. So 3.3166 is less than 3.333333. So square root of 11 is less than 3 1/3. Square root of 17 is 4.12, and then I have 4.03. Okay, well, our whole numbers are the same, so that's why I'm looking at our tenths place. We have a 1 and a 0. 1 is greater than 0, so square root of 17 is greater than 4.03. And then I have the square root of 6.25, which if you put in your calculator, it'll come out to exactly 2.5. 2 1/2 is the same as 2.5, so they are equal. Okay, go back into your book if you have more questions, and you can read the chapter for some more information. Make sure you have these down for notes, and make sure you've updated your chapter 3 vocabulary page, and also go on Naiku and do the 3-4 quiz.